Hi, this is Mike Stevenson from Connected Systems Consulting Limited. In this video I'm going to talk a little bit about an initiative I've been working on with some customers around the idea of a cloud-based development lab. Before we get into the video, my background is that I'm a UK-based freelance consultant specialising in Windows Azure, BizTalk and integration. I've also been part of the MVP program for over 5 years now, and I'm quite heavily involved in the UK Connected Systems user group, and also there's a few extra details on the screen about the things that I get up to. In the video I'm going to talk a little bit about some of the challenges we face in modern day development and how we came to this idea of a cloud-hosted dev lab. I'm going to talk a little bit about a few of the changes that happened that led this idea to be feasible, and then some of the kinds of dev lab you may create. I'll talk about some of the access challenges and the process we go through to actually create one, some of the use cases where your organisation may benefit from this, and some of the costings that could be associated with that. In this particular video I'm not going to go into any demonstrations. I'll do that in a future video. This video is really just aimed at the concept and the benefits of doing this kind of idea. In modern day development we have many challenges, but with some of the customers I've worked with recently there was a number of specific challenges that were really sort of hammering our development efforts. The first of these challenges was that typically organisations have many partners involved in delivery, so whereas traditionally you may have just had a small in-house development team, a lot of the customers I've been working with have actually got a combination of their own in-house development team, some external but locally based contractors, and then in addition to that we may have other businesses or business units within the same organisation but in different parts of the world who may be helping us develop projects. We may also have external partners, which could be either nearshoring or offshoring partners. So for example, I've worked with organisations who've had partners based in India and Romania, and this brings all kind of challenges around how do you get these guys to all work as a team. And in this particular video I'm not really thinking about the kind of team dynamics sort of things. I'm really thinking about physically how do we get these guys working on the same code base in the same delivery patterns, and typically there would be all sorts of networking and security challenges around that. In addition to that, we also have a lot of challenges where where as a development shop we want to try out some new technologies or test a new architecture idea, but often the security team may be quite concerned about what that means to the on-premise infrastructure. And as an example, if we wanted to do a proof of concept, often we'd have to go through a significant risk assessment. Many companies also don't have isolated developer networks, which kind of makes this problem even more challenging. And rightly so, the security teams would often view developers as one of the biggest threats. In addition to that, we also have a bunch of challenges around infrastructure teams struggling to keep up with development teams, and that's particularly true in companies who've adopted more agile practices. Normally agile would be driven by a development team and they're trying to push ahead and implement change at a really quick rate, but the minute they hit a sort of touch point on an infrastructure team, typically you see things slow down and they fall into things like change control processes. But actually when you're developing quite new architecture changes for your organisation, sometimes you don't really know what you need to ask the infrastructure team for. So how do you figure those things out, and how do you figure them out in a way that's going to help your team keep going at a good velocity? Typically on-premise infrastructure takes a while to provision because it's more than just the case of setting up a machine. It can be things like change control processes, approval processes, and often lots of people get involved in these kind of things. Additionally, when you're doing new architecture stuff as well, infrastructure on premise can be quite expensive, so there might be a big upfront cost before you can do anything, and that can often be problematic for some projects. So these challenges led us to the idea of a cloud-hosted dev lab. Well, what is a cloud-hosted dev lab? So for us that was a small sandbox containing some machines for development purposes, but it's actually hosted in the cloud as opposed to hosted on-premise. In this video, I'm going to talk specifically about the use of Windows Azure to host our dev labs, but many of the topics, many of the sort of ideas in this video could be equally applicable to a provider like Amazon. Now, why did we think about the dev lab? Well, as I mentioned in the challenges earlier, one of the things is to increase the velocity of our development team and to remove some of the common infrastructure shackles that the development team would have on them. It also allows us to more effectively work with our partners, but at the same time it allows us to increase the security, because a lot of the prototyping, proof of concepts and early development can be taken offline, so it's away from your sort of valuable on-premise assets, and it also allows us to make some significant cost reductions. So at this point I've talked about some of the challenges that we can solve with this particular this particular solution, and also it's quite obvious that there's some real big wins here. But why haven't we done this before? Well, in 2013, I can't remember the exact date, but it was sort of like late spring, there was a couple of key changes around Windows Azure and MSDN that really supported this kind of approach being undertaken. So the first of those changes was that Windows Azure VM pricing changed, and that meant that you no longer had to pay for a VM when it was in a stop deallocated state. And this really just made things a bit simpler, because previously you had all the hassle of completely removing a VM to stop you being charged when it wasn't in use. But now you could actually leave the VM deployed. You just had to move it to this stop deallocated state, which is a lot simpler from a sort of maintenance perspective. There was also a change in the MSDN licensing for cloud, so I've included a link to the MSDN and Visual Studio document here, where basically it says that most of the MSDN software is now supported for use on cloud VMs such as Windows Azure. Basically that means we can use Visual Studio 2012 on a VM in Windows Azure, and from a development perspective that's a really big change. In our approach to improving the way we were doing development, we had two types of dev lab, and the first of these is displayed on the screen here. Now you can see one of the first things is at the top left we've got Team Foundation service, and by hosting our code in the cloud, that means we're now able to access it from many different places, which is really good. That means it's not on-premise anymore, and it means some of the developers who aren't based in our company can access it much easier. Now it does, even though you can do that, there's still some other challenges to consider. So for example, I'm a big believer in having some consistent development environments where all the developers are working on machines that are of the same build and have the same stuff on them, and you don't get into this scenario where code works on one machine but not another. So I've never really been a big fan of having developers get the code locally onto different machines all over the place. We want them in a controlled environment still. And as you can see here in the middle, we've actually got represented by the cloud some Windows Azure virtual machines, and this is really what I'm referring to as the dev lab. In this lab we've got a domain controller, a build server and n number of developer machines, and what that means is that you can see in the fictitious scenario at the bottom here, we've got Acme, who is our company, Contoso, who's one of our delivery partners based in Romania, and Northwind, who are based, again, one of our delivery partners but based in India. And we're all trying to work as a globally distributed team but on the same development environment, and by putting these machines in Windows Azure, that means we can quite easily all access the code bases. We can allocate machines in Windows Azure to different developers in each of those companies, and we can all really access this code in a sort of nice tidy way now, and this really puts us in a good position to do this development. The key thing about this particular lab though was that it was isolated, and by isolated I mean it's not connected to any local data centers or any resources on premise, and that's a key point. So for example here we're really working with code where we've got some effective techniques to mock or stub out any external dependencies, outside of that code base, and that's really key to supporting this isolated concept. That's not always possible with every code base, but this is our preferred dev lab where possible. The second type of dev lab is what I refer to as a connected dev lab, and you can see the diagram looks very similar. However, the key difference now is over here on the right hand side we've now got connection to the Acme data center, and we've actually moved the domain controller now, so the machines in Windows Azure are connected to the local domain controller, and to support this we've got the represented by the red icon here is the Windows Azure site-to-site VPN, and that'll basically let us create a kind of an extended data center scenario which will connect servers on-premise to servers in the cloud, and they'll be to communicate both ways. And as I mentioned previously, this wouldn't really be our preferred scenario because some of the things we want to do is remove the security sort of concerns around some of the development. But there may be cases where you're developing, say, an integration component, and we've seen this quite a few times where you just can't stub out the dependency. Typically, if it's some kind of sort of legacy application, or maybe a sort of old style database, and for whatever reason you can't just create a stub of that in the dev lab, or maybe for licensing considerations you can't create a copy of it in the dev lab. So in that scenario we can basically create a network between the two data centers, and we can access that legacy resource on premise, and that lets us still do all the things we want to do, but it's just a little bit more sort of fully featured. As I say, that this will mean some of the challenges we had earlier with things like our security team will still exist, but we can still accelerate our development much quicker and much cheaper by having the bulk of the lab in the cloud. So if we have all these machines in the cloud, accessing them becomes the next question. If we're in the scenario of the isolated dev lab, there's two easy ways we can do this. The first one is public access via a port which is exposed on each machine, and by default each machine would normally have an RDP port open on it. Now what we tend to do in our labs is we actually when we create the machines we set them all to have the same port open, not one of the obvious ports but a specific port number, and that makes it easy for any developers to access any of these machines. The next option is the point-to-site VPN. Now when we create a dev lab we always set up all the Windows Azure network and stuff so the machines are all connected together and part of a domain, and the point-to-site VPN means you've got solutions for situations if your organization means you can't just get straight out of the machines with RDP. You can actually use point-to-site VPN, which would use SSTP over HTTPS, and that means you can get out in a sort of a way that's going to be a little bit friendlier with your firewall. And the point-to-site VPN also means that you could potentially lock down the machines by not exposing a public port if you were a little bit cautious about some kind of external attacker being able to get to your machines. The connected dev lab basically has the same scenarios, but it also has the option of the site-to-site VPN, and that means that if we go back a couple of slides to the diagram, if you were in Acme you would be able to access those machines as if they were just part of your network. But if you were in Contoso or Northwind, who were the development partners based in other countries, they wouldn't be within that data center to begin with, so they'd still have to come in via the point-to-site VPN or the public access. As you can see, there's quite a few different options here, but this is really good for supporting different partners around the world all wanting to develop in the same environment. The next question is, how do we create a dev lab? As I said at the start of the video, this particular video is going to talk about the concept rather than actually doing a walkthrough demo, which I'll do at a future point. But at a high level, the creating a dev lab falls into 3 steps for us. The first step is about TFS service. So we'd create a repository, we'd set our code up in that repository. The next step becomes a Windows Azure step, and we do a number of things. So firstly, we need to create a subscription for that dev lab, and most companies probably have slightly different ways of how they manage their Azure accounts and subscriptions, but for us, from a billing perspective, it becomes really easy to have a dedicated subscription for any dev labs we want to create, and then we can very easily manage the ongoing running costs of that lab. The next step is to copy a VM template. Now, if you have one already, you can basically just copy that up to Azure, or you can create a machine and then sysprep it and create a template from that. So there's a couple of options here, but basically that's going to be a machine with any software you want pre-installed. The next step would be to create a domain controller, and for us we usually use the default Windows Azure Windows 2012 machines that are on the Azure gallery, and then we can configure that to be a domain controller and to have some groups. We'll also create the virtual network when we do this. Then we build our first server, which we usually use as a build server, and after that it's just a question of creating a set of development machines, and it's usually a good idea to use some naming conventions around your machine setup to ensure that you can easily manage what machines what and who's going to be using it. The final step is we have this idea of an environment lab controller. So here we have a machine in Windows Azure where, if you imagine, we've got multiple dev labs, and we want one machine in the middle that basically manages the start and stop of those labs. Now here we're basically trying to save cost is the key thing. So if we imagine that overnight developers aren't going to be working in the evening, maybe this isn't quite as true a scenario if you've got people all over the world, but in some cases where we've just got a local team, they probably finish work at 6 o'clock, so for most of the evening we'll be paying for a machine to run that's not being used. So here we use the lab controller to just run a bit of PowerShell that'll shut down the lab in a controlled fashion when everybody finishes work, and if they've accidentally left a machine on, and then it'll start the lab up again in the morning, and that really just saves us the cost when the machines aren't being used. We can also typically we'd start the domain controller in the build server and then let the developers just manually start the machines in the morning, because there's no guarantee they're going to be working in that lab that day. So hopefully you can see a number of benefits for this dev lab concept at this point. But some of the use cases that I've seen while working with customers have been anything from just normal development activities, where if you can save some money by just shipping a bunch of development into the cloud, that's pretty cool. I've seen sensitive proof of concepts where we've got some stuff we don't really want on the corporate network because we're just trying some stuff out. Security guys are a little bit concerned about it, so we can just put it in an isolated dev lab, do whatever we need to do, and when we're happy and we understand it well, then we can look to potentially move it on premise if we want to. I'm a big believer that the reference architecture one is a quite cool way of doing it. So the idea here is a lot of companies have their production architecture, some test environments, but their architecture team very rarely have a reference architecture which is actually physically some systems. They may have PowerPoint or Visio diagrams which often get out of date, but if you've got an actual environment that sort of simulates some of the key architecture patterns, then you can go and play around and try things out and explore new R&D ideas with your reference architecture, and also you can use it for potentially for training of new people and stuff like that. And I very rarely see this, but I think the idea of doing this in Windows Azure could be quite interesting. The big ones for us also have been shared development with partners outside of the organisation, and also development across business units. So the idea here is, if you're working in a sort of really big company who has different businesses around the world, but you've got developers in one business unit who might hit a quiet time, but they may be in another country, for example, you can just share them across into another business unit, do a few weeks work, and then when their project picks back up they can go back, and we just really empower developers to work much better as distributed teams. Let's look at some of the costings now. So here's an example from one of the customers I've worked with where we look at the infrastructure on premise. Now, if I wanted to create a dev lab or development setup which is based around a bunch of virtual machines that are centrally hosted by our infrastructure team, typically there's about a £2,000 per machine internal cross charge to set a machine up. And normally if I wanted a lab for 8 developers plus a build server, I can expect to take between 1 and 2 weeks to set that up. Now, that's going to be about £18,000 before I've written a line of code. Hopefully that's really obvious what the problem is here. It just makes these kind of things really difficult, and you've got all sorts of management approval to do for things like that, and you're just on the back foot from day one. Let's compare those on-premise costs against the cloud version. So we've got a Windows Azure Enterprise Agreement, and here's 2 usage scenarios for the same lab with 8 developers. Now, remember back a few slides ago where we talked about how when the machines aren't being used you can deallocate them, so you don't really pay the compute charge. You still pay the storage but not the compute charge. So if we've got a lab which is undergoing quiet use, typically we'd have 3 cores running for 8 hours per day, which is going to cost us, based on the Windows Azure Enterprise Agreement price, is about £1 per day. And that's 1 core for the domain controller and 2 for the build server. And the storage costs is going to be approximately 20p per machine per day. So for our 8 developer scenario, we're talking on a day where nothing's really happening, there's no developers really working on this lab, about £2.60 per day. In the busy usage scenario, we've got 8 developers who are working flat out for 8 hours a day. We've got the same cost for the domain controller and the build server, because they're going to be just running during normal core hours to make sure if anyone did check a change in, we've got the standard continuous integration scenario going on. We've still got the same storage cost, but the additional cost now is 16 cores for 8 hours per day, which would cover the 8 development machines. So that's going to cost about £5 per day. So you can see here we've got approximate costs of between £2.60 a day or £7.60 a day for the lab against £18,000 before we've written a line of code. I think to pretty much everyone that cost benefit's obvious. So let's just make a couple of additional notes on the pricing. So EA pricing's quite complicated, and that's my interpretation of the prices plus some looking at the usage from an actual customer scenario. Those were about the prices that we came out with. Just double check your own labs, and just bear in mind that if you use any additional Windows Azure features, you'd have other costs associated with that. But key things here are that the lab can be shut down, which means you get rid of most of the compute costs, which tend to be the biggest cases, and these costs here are based on a Windows Azure Enterprise Agreement. Now, if you're going to be doing any pretty serious development with Windows Azure, an enterprise agreement's a really significant cost saving, and if you're investing pretty heavily in Azure, then it's definitely something to think about, because I'm sure you'd quite easily get near the sort of threshold for benefiting from an EA. So definitely something to look at. Let's take a look at a large-scale dev lab example then. So I've talked about this idea of a company with different businesses around the world, different partners, all working all over the place. Now, here we've got take the Acme example from earlier. So imagine Acme has a business in the US, a business in the UK, a business in Australia, and a business in France. And in each of these businesses, they've got a bunch of different dev labs. So you could have a different dev lab for different scenarios. So maybe they've each got a dev lab for integration, one for proof of concepts, one for reference architectures. Maybe one of them has, maybe the USA is doing some CRM development, and it's using CRM online and a bunch of Azure stuff, so that might be a really good dev lab scenario. Each business can have different labs, but we've got this idea of the centralized lab controller, which I mentioned earlier, which would basically be a machine that's running all the time, and it can run some PowerShell to shut labs down, off and on as appropriate, using something like Windows Task Scheduler. That'd be a really simple way of doing it. You could probably do something much more sophisticated with something like System Center if you had that available to you. You can pretty much do the same stuff. But if we look on the right hand side here, if you imagine we've got these developers who, we've got the UK devs, US devs, and we've got some partners who are offshore. Now, let's say, we have the partners typically, who are working with Australia, and we've got the Australian devs here, and we're all working in a lab over in Australia. But also, we could have a dev in Australia who's really, really experienced at a certain thing, and he might for a couple of days go and help the UK out because they're having a few problems. And we can start leveraging the experience and getting this guy, to have a machine in the UK's dev lab, which he may just use on occasion to do some troubleshooting or something like that. And it gives you a much freer way to leverage your global resources then, because in the past, if we had this challenge, I had a customer where they had some stuff going on in the UK and some guys in Denmark, and we ended up swapping some emails between me and the guys in Denmark because they need a little bit of help now and again. And actually, if we use the dev lab scenario, I could just have a machine in their dev lab if it was in Azure, and I could access it, and they had their own Active Directory setup and on-premise setup, which just made it that bit more difficult for me to help them. Whereas if I can just go into the cloud and access one of the machines in their lab, I can just fix a bug that they might be having problems with, and suddenly we become a much more effective team because of this global distribution. So finally, in conclusion, this was the first of my videos that I think I'll do about this dev lab idea, and we were really just trying to touch on the concept and the high level sort of discussion points in this idea. And I hope at this point, I'd love to get people's feedback, because I haven't really heard that many people doing this. But we're having some real significant success with this and getting really good stories about it. But to me, when you think about all the different aspects, it's really just a case of why wouldn't you do this? I expect a lot more companies to be doing this kind of thing in the future, and it just there isn't really any downsides that I can see. Everybody's been really excited about this, but I'd love to get some feedback off people. So please feel free to throw some comments on YouTube, where hopefully you'll be seeing this video. Thanks very much.